Hi, this is Jean Lozela. I am the co-founder of InferTheta, and I'll show you how to use our probabilistic graph technology for AML modeling. So what you're currently seeing on the screen right now is called the Bayesian network. I won't go into the details of the math, but to explain quickly what it is, it's essentially a graph that lets you answer two types of questions. Given what I know about a situation, what is the probability that something happens? Or the opposite, given I know something happened, what is the most likely cause of that? So here, for instance, the objective of this network is to detect the probability of a potentially fraudulent transaction between several jurisdictions. So here, France, Europe, and UAE. The probability that someone manages to exploit a joint gap between jurisdiction. And so that's why you see four layers, four categories on the graph here. The first layer, which are potential observation about the transaction. The second layer combines and contextualize those different pieces of data to tell you what is the most suspicious about the transaction. And the third one gives you the probabilities of a jurisdiction, investigating and actually taking action to stop the transaction. And finally, the fourth one gives you the probability of the transaction being blocked by one of those. So here I would just showcase really quickly how you play with the model, how you do inference. So let's say, for instance, you know that at some point in the way the money was transferred, crypto was involved, and it was also transferred to countries with low transparency about financial rules. So you'd say true, and you can see in real time every time I make an observation, the probability of the transaction being successful decreases because the probability of a jurisdiction taking action increase. But even if everything is true, you still have the transaction, it still can go through because you still have uncertainty about the jurisdiction. And I will now show you the opposite. So for instance, that's called backward inference, what I'm gonna do. So you know, like you wanna know what is the probability that despite all the jurisdiction being covered and should take action, you can see that there's still a 3% probability that the transaction is successful. Obviously, the figure itself here doesn't matter, it's just for illustrative purpose. It's just to show you that you can, with this kind of model, you can, let's say, you don't think in silo. You can see how the variables can affect each other. So here again, it was just a small example of graph. It's possible to make graphs that are way more complex with hundreds of variables and each with several traits. And I've also made tons of independence assumption between factors, but again, it was just to illustrate that with such probabilistic tools, despite uncertainty, you can still exploit the info or intuition or expert knowledge that you have about the situation, understand the causality between variables, and have a clear visibility of all of them, make informed decisions, and are able to explain your decision for compliance purpose if needed to.